Go. Okay, I think we are live. Sweet. Alright, what's up, y'all? Romance of the Three Kingdoms. Yo, what's up? Hi, Harsh. Am I saying that right? Reddit is the most popular search engine. Only people who don't know that team at Reddit. Okay, fair. So instead, we resort to using Google and appending the word Reddit at the end of our engine. Graham thinks this means social hasn't actually reached its peak. I guess this is kind of like to hype up Reddit, as because they're about to IPO, which is kind of interesting actually. What was each platform generating at its peak buzz on Google? Oh, interesting. Actually, this is not that bad. I think it's kind of interesting actually, because if you look at like all the social media networks, there's like this is actually pretty telling. Like when there's a peak and then fall off based on Google searches, you can actually tell like what company is actually about to trend and live on and which one isn't. So I guess this kind of makes sense. Like, you know, TikTok had its peak heyday here. Twitter's back on the rise actually. This is actually very interesting. Facebook's declining. We all knew that. Instagram is peak and still kind of hovering. This actually kind of does represent the sentiment around a lot of these networks. This is actually really interesting. So why are people searching specifically Reddit? The short answer is that Google searches are clearly dying. The long answer is that most of the web has become too inauthentic to trust. This is somewhat correct, although to be fair, Reddit is just as much a social network as any other social network. It's just searchable. That's really it, or publicly searchable, I should say. I don't need to tell you that Google's search results have gone to shit. Yes. SEOs are optimized for ads. Yep. Google gives decent results, but you realize that you've already been self-censoring yourself from most things you want to search because, you know, subconsciously Google isn't going to give you that good result. I think this is somewhat true. You know, there's that meme of like if you're looking at page 10 or 12 in a Google search results, you know you're really trying. And lately for me, for Stack Overflow, I've been kind of like definitely looking at pages 7 and 8. So yeah, I guess Google is. This does bring up a very good point. And like the way Google makes revenue is through ads, right? So it's going to prioritize a lot of the search links that are optimized for ads and what it collects. So there is that incentive out there. I do fully agree. I think this is the point the author's trying to make here. Early adopters aren't using Google anymore. Has Google become qualitatively worse? Once you get off the first or second pages, the results get even worse. The pages are unrelated to the query. Somewhat true. Google's no longer producing high number of search results. Why not try writing a search? This is still. Yeah. Okay. So basically, this is just saying the same thing I mentioned before. Of like you're basically forced to look deeper and deeper into the search results to find something meaningful. It's obvious that ads create misaligned incentives. Yes, incentives are very, very powerful. Currently, the predominant business model for commercial search engines is advertising. The goal of the advertising do not always correspond to providing quality searches. Yes, we expect advertising funds to be inherently biased towards advertisers. Correct. Furthermore, advertising income often becomes an incentive to provide for quality search results. Correct. Ooh, yes. They stack a lot of ads at the top. Yeah, I guess this is kind of like when you think about it, like let's think about it from a business perspective, right? And I think this kind of like ties into the whole Meta Facebook stock crash that we've seen before. So like if I think about like a business, how it grows, I want to say Apple, right? What does 10% year over year revenue growth look like? It can mean a few things. It can mean getting more iPhones into 10% more users, like capturing more and more of the market. That's one way. The second way is to jack up the prices of the iPhones or all its products by 10%. That'll produce the annual by 10% year over year, right? Those are just basically two dimensions along which Apple can operate. And so do you can also say, hey, just go into every single country in the world, and then just say the number of users will multiply by 10%. Although, to be fair, I don't think that's quite as effective. But you get my point here, is that there's two very obvious avenues for Apple to raise its revenues, and it's very obvious what happens in each one of these cases. You can only go to so many people in the world, right? So the next thing is to jack up prices. Now, if I jack up the price of an iPhone or Apple Music by 10%, are people still going to pay? Yes, absolutely. So the only incentive for Apple is really to raise prices or lower costs. And up until now, Tim Cook has been very good at lowering costs. But let's take something like Facebook and Google. This actually gets more interesting. What does 10% year over year for Apple and Google, not Apple, but Google, Facebook, and all these ad tech platforms, what does that look like? That basically looks like, one, they jack up the revenue, they jack up the prices of the advertisers. Two, they get more people on the platform to use Google, but everyone in the world freaking uses Google. Google's synonymous with searching, so that avenue's closed off. So what's the other thing? To flood more ads to the user, which is exactly what's going here. So which means that in order for them to keep up their revenue growth, they have to flood you with 10% more ads in order to keep up like 10% growth. Now, to me, that doesn't sound like a very good business strategy or structure at all. To me, it sounds like you're cannibalizing your own quality. But Apple, like if you take, that's why like Apple, Coca-Cola, all these other businesses that are very high quality are actually very good. So let's go back to Coca-Cola. This is the company that I really think is the golden standard. Coca-Cola, highly addictive chemicals, sugar, caffeine, and hearts and minds, right? They will basically pay schools to only host Coca-Cola products. So they captured these the consumer base at a very young age. And it turns out once you get addicted to that brand and their substance, you're gonna drink that for the rest of your freaking life. I mean, like that's basically how it works. So 10% year over year growth for Coca-Cola just basically means just letting the population grow or making someone drink an extra can of Coke. And chances are that's pretty much what it's gonna look like, right? So considering that Coca-Cola is in every single country, except for North Korea and I want to say Cuba. My point is that Coca-Cola is everywhere, right? And their distribution network is basically the same as a software company. So in other words, 10% year over year growth for Coca-Cola just means letting the population of the world grow. That's it. Chances are, if the population grows, then some percentage of those people are going to drink Coke every day for the rest of their lives, and they're going to drink for their, it's a self-perpetuating machine. So 10% year over year growth for Coca-Cola is just on autopilot. That's it. So compared to Apple, where it's not as much a necessity to own an iPhone. I mean, yes, you do need a phone, but the story's not as obvious as drinking addictive chemicals from the day you're born. That's Coca-Cola's power. Literally, it's human nature. You can't fight that. So going back to this, that's kind of why the story's not obvious with Google how you can raise your revenues without cannibalizing your own core product. Google's pretty addictive as well. Try using a different search engine for a while and you'll see. So is Chrome and YouTube. I think that speaks more to the quality of Google searches compared to anything else. I think at that point it's just more like brand power. So for instance, there's nothing wrong with using DuckDuckGo or Bing. It's just it's just people aren't used to it. So if the quality of Google goes down, then people will definitely go over to another brand. Now, of course, the brand power of Google is so strong in our minds because we've used it since day one. So there is that hearts and minds aspect, the same as Coke. But to me, it's also cannibalizing the core quality product of it. So for instance, let's go back to the Coke analogy. Imagine if Coca-Cola decided one day, you know what? We're gonna change the recipe. And we've seen this actually before with the new Coke recipe. The moment Coca-Cola changed their fucking recipe and made it public, everyone lost their fucking shit. I mean, to be fair, Coca-Cola has changed their recipe over the years, from sugar to corn syrup to a bunch of other shit. As it evolved. But overall, it tried to keep the taste the same. Imagine if Coca-Cola actively said, you know what, we're going to take out all the sugar, we're going to take out all the addictive chemicals, and make it not as tasty. You're going to fucking lose your minds. And you're going to say, hey, this tastes different. You ruined my fucking childhood. So imagine that story painted onto Google. That's the worst case scenario. But I think it's just going to be a slow burn if we're actually going to experience the worst case scenario. Wait, Coca-Cola has much lower growth than Google, right? I don't think so. You know what? Remind me at the end of the stream to go over the Coca-Cola numbers. But I'm fairly certain Coca-Cola has like almost 5 to 7% revenue growth and then like 10% net income year over year. Something like that. And it's pretty consistent whether rain or shine. I think it's like at market value. So if you look at it over the years, like for the moment, like I think this, like we did this exercise with Warren Buffett. Like literally it's like 25% year over year compound annual growth rate since the day he bought into Coca-Cola. And remind me to do that exercise with you after. Google increasingly does not give you the results that you typed in for. It tries to be smart and figure out what you really meant, yes. Except doesn't give you exact matches anymore, which is quite bizarre. Alright. Why are people appending Reddit to the end of their queries? Does it cut... Okay, I see. So people are appending Reddit to the end of their queries to try and probably get higher quality search results because those results and comments have probably been vetted by... are being input by random people on the internet. But you still can't guarantee the quality of that shit. Large portions of the supposedly human-produced content on the internet are actually generated by AI networks in conjunction with paid secret media influencers in order to manufacture consumers. This is actually true, yes. It's basically like trying to say, oh yeah, like the old algorithm of like backlinks and whatever. Now it's like being tilted in the way of like social media influence and driving internet traffic and ads. I think that's absolutely true. So how can we regain authenticity? You want to know what real genuine human thinks about the list Lenovo laptop? Then you go to Reddit. Interesting. Yeah. So this is like kind of a way to make Google's quality of search results better. I see. So he's not. I don't think he's saying quote unquote Google is dead. I think he means more that Google is just a proxy for Reddit. But it's like, it's hard to say. So let's take a look. I work for Google Search Patch or feedback. You send the post that the quotes don't give exact matches. They really do, honest. Put a word or phrase in quotes and we'll match. If anyone has an example where they feel it doesn't, please let me know. Here's why I think people are often quoting Google doesn't work when it really does. We match alt text. Yeah, okay. We match text not readily visible. Pages, punctuation. Yeah. So they do like some kind of text sanitization on it. Punctuation comes into play if we did a quote. So it's like dog, cat, and there isn't much text that says dog, comma, cat. Then we'll look without punctuation. Yeah. So it's like some text sanitization that it does there. I think that's probably what they're trying to get at. Google has just record profits. You are obviously wrong, and Google isn't dying. I never said that Google wasn't making money. In fact, Google is really squeezing every last cent out of ads without regard to search quality. I expect the revenue to be an all-time high. Yeah, the thing is that you can say this is kind of another point I kind of like have a problem with, is that when people really make like these extrapolations for business, they only really do it for the past like 2-3 years, like the short term, right? But the thing is that the biggest events that move the markets and change the world are the ones that people don't actually see. They're the ones that are like in the P90, like the 5 sigma figures or whatever, like the P9999 or whatever cases that completely tank the market or change the market. Those are the really big events that change the world. You know, you can any idiot can extrapolate the last 3 years, and usually the market prices it in. You know, that's why the market just completely like goes on this fucking crazy bull run or fucking crazy bear run, because they only extrapolate the short run. They don't actually take into account like the quality of the business or any other topic like that. Look at the history of like any mania. People just assume that stocks grow to the sky. And so like if you Google Nifty 50 from the 1970s, it's pretty much an extreme example of that. The .com is just the exact extreme example of that. They assume that .coms were just gonna grow forever, because they only extrapolated the last 3 years. You know, and then like there's also a time when everyone wanted to join venture capital instead of like traditional banking, where Goldman Sachs at one point had trouble hiring, and it was literally just because they extrapolate because people believed that venture capitalists were going to beat traditional finance, and that's only because they took the last 3 years of venture capitalist performances and then just said, hey, yeah, these guys are really fucking good, and they quit all their traditional jobs. But if you look at the record of like venture capitalists, they're basically like utterly shit. Like it's like I think it's like they work below the market. I think they struggle to maintain even 6 to 8% return on capital if you look at the entire record of the entire business. So seriously, what are you talking about? My search results are perfect. I think your search results are perfect. Then you probably would be right. If every single person agreed that Google search results was trash, then Google would already be bankrupt. That's correct. I think 20% Google search, and this is just like more like, um, this is just more like an intuition from the author. So, yeah, I think this is just more like subjective. We're just kind of like conditioned to use Google at this point. But when the quality goes down, people are going to start looking for alternatives. Like everyone just says, just Google it. I think that's a pretty strong indication that Google has entered our lexicon pretty well. But there's this nagging, I would say, there's a thing that the incentives are to cannibalize its own quality for profit. That's there. Like for Apple, you know, like it's like for Apple, the incentive would be to make the quality and costs of iPhones and everything else much lower. But is there a need to do that? Not really, when you can jack up the prices and make the consumers pay for it. You know? And like I said, if you force the consumers to pay 10% more for their iPhones, they'd fucking do it. No problem there. There's no reason to decay your what's called? To cannibalize your own products. With Google, it's like there's no fee to jack up. So the next thing, you're trying to monetize free. So the only thing you can do is flood more ads. So that's the primary difference. It's where the incentives lie and how you respond to them. So reports of deaths are greatly exaggerated. Correct. It's like everyone's just being overly optimistic or pessimistic about things. But I tend to lean more towards pessimism. Only because I like to be a little bit more careful about the things I consume and the businesses I try to engage with. Random Redger explains better than I did. I think I understand why the article is trying to say. It's not saying that Google search terminology is worse or that Google doesn't use search. It's saying that people trust less of Google compared to what they see discussions on Reddit. Yeah. Which is kind of interesting, considering that would you trust random articles from random strangers on the internet or random comments from random strangers on the internet? It's kind of shit like that, actually. It's really hard to determine what is quote-unquote better in terms of quality, or is it just a perception of quality? It's kind of weird. Anyway, we're gonna bring on my clients soon, so I see the viewers dropping. So let's see what's up. Okay, let's bring him on. Hello? Yo, hello? Oh, hold up. I can't quite hear you. Give me a sec. Voice and audio, input, out. Ah, there we go. Hello?
Hello?
Yeah, what's up?
Doing good. How about yourself?
Hey, doing good, yeah. How was your studying?
I would say it's been good, but man, some points I'm not liking. Like I was able to solve a lot of the exercise of subset and get a lot of insights and didn't repeat the same errors. Like for, I would say half of the problems, but for some that I like still struggling, like especially the last ones. I did follow the clear rule sets that you said to me, like walk through the idea, test the idea, and then test your first idea, and then test over again your code. I followed all of this, and yeah, wrote the rule sets. But man, still, I would say that especially for the problem challenge, it was like one that I recorded. I put like problem in front of it.
Okay.
And that was like the problems that was more concerning me because, man, I'm putting all my like work power and it's like not improving where I had to improve. You know, I start to get mad as you mentioned, like because. But yeah, like. Counting this, I feel like for some problems, following your rule set made them much easier for me. So it was not like all about bad.
Okay. So basically, you followed the rule set. It was a little bit better, but you still got a little bit frustrated.
Sure. Yeah.
Okay. Follow rule set. Okay, still. Do you have a problem? Like, can you can show me where you got
Yeah,
frustrated?
I
And
have.
you got fucked up.
I have. Actually, I have the video. I record this one.
Perfect.
That was great.
Send it to me. Yeah, I want to look at like all problem sheets. Let's focus on the good. Let's focus on the good stuff before we get to the bad stuff. I'm
For
happy to
sure.
hear-
Yeah, that's definitely the focus.
Yeah, I can tell that you're still a little bit frustrated. Let's do something a little bit positive before I start insulting you and tell you suck. You know.
Yeah. I don't know if you have the link for this drive where I have like the videos.
Okay, so you uploaded them to the drives again. Okay, let me see.
Yeah, the folder is called Replay Coding Practice.
Got it. Yep.
I don't know if you. I can share if you
I
don't
got
have it.
Cool. All right. So which problem do you want? I see 3 problems in here. Which one do you want me to look at?
The one with the title of like problematic. Problematic. I put like this. Yeah, that one.
Got it. I'm gonna download it. It's 450 megabytes. I didn't get a chance to look at it. I thought you were gonna send it to me at the session start. I guess I would have looked at it beforehand. But it's fine.
Yeah. The other ones, I would say that was like better than like in our coaching session. You know, I solved the serialize and error tree, following like not like remembering, but following the right approach to this, like not rushing and like being very methodical and think objectively, and was much easier to even fix my bugs during the code.
Perfect. I
But
want to see that one.
yeah,
Which one's that one?
the ending in 17.
213. Wait, which one? 215?
No, just a moment.
Yeah.
I just need to make sure here.
Okay.
I'm not sure. Sorry.
It's fine. Don't worry about it.
Is the one ending in 12. 2912. 2912.
2912. Okay, I see it.
Yeah.
All right, let me download it. Let's look at this one first, because it'll be easier to talk about. Did you compare your... if you look at my guide, I think I posted the answer to it.
Uh-huh.
Yeah.
I compare with the video. I think you have the video like solving this problem and like reviewing the mistakes of your clients.
Oh, perfect. Yeah. Okay, great. I'm glad you watched it. Yeah.
I compared with this. Yeah.
Excellent.
Okay, the problem
Okay, so let's take a look at this. Oh yeah, I can't share my screen, but let's see. Oh, the quality on this is like kind of bad. Can you check the quality? Like, what's the quality that you recorded, by the way?
Oh, I guess I didn't check this. Let me check.
Yeah.
First of all,
I see you're using like what Ubuntu.
Yeah, I'm using Ubuntu, but I think I can fix this on the OBS configuration. I'll check this for the other ones.
That's fine. Yeah. So
Actually, there's one thing. I think if you download, you can get like better quality.
yeah, no, I
because
downloaded it actually.
Oh, it didn't get better.
Maybe wait, hold up. Maybe it's my thing. Let me actually try opening with VLC then. I mean, give me a sec. Because I do see it's like 330 megabytes, so it's kind of strange that it would be crappy quality at 330 megabytes.
Yeah, I think
It's
was the quality actually. I recorded in bad quality.
okay. That's fine. All right. So I see that you're walking through. I'm going to like try to judge it based on what you do here. Sometimes I'll use the audio, but okay. So I see you're walking through the problem. Great. Perfect. Good. Good.
Yeah.
Well, let me listen to what you're saying here.
recursively
I think it's good.
to 5, but before this, I can parenthesis,
Okay.
and then traverse to 5. There's nothing else for me to traverse. Then I'll traverse to 6. So I will check that 5 doesn't have nothing.
Okay,
So-
cool. Yeah, so you thought of an idea of like, okay, this is kind of like how I want to go with the traversal, parenthesis 1, parenthesis 2, parenthesis 5, 6. You kind of imagine what it might look like. And then you, I guess you kind of like saw, oh yeah, this like kind of looks like a blocks and stuff. And then you actually walked through the idea to try and validate it. That's good.
Yeah.
I'm going to tell you for a lot of these problems. Sorry, go ahead.
Create the idea based on the walkthrough, not like just guessing the idea. Yeah.
Correct. Well, I mean, you can guess the idea, but then it's like you're gonna need to validate it. And very often, just simply walking through the problem is like gonna give you better ideas than simply just like guessing and then YOLOing it. So
Yeah.
like this is I'm okay with this. Usually when you try to come up with a solution, it's never gonna be it's almost rarely gonna be perfect the first time you do it, right? There's always gonna be like some negotiation back and forth. But
Okay.
following the right what's it called a formula, or at least
Approach.
the right approach, you're gonna be more likely than not to arrive at a very concrete answer.
So I actually don't gonna.
Good. That makes sense.
So that's basically this.
Okay, so to
write
comma-
a few things here. So once in
I think if you
What's
go
the-
in the practice diary, I just put the timestamps like to
Okay.
give you an
Yeah,
understand
let me
where
do that.
what I'm doing.
Okay. Yeah, that'll be helpful because
Yeah.
it's like trying to hear that. Okay, so
I
let's
think
practice
it
diary.
was the last like the one before the last. Yeah.
Got it. Perfect. Let's see. Row number 47. Got it. So let's actually see what you
For
wrote
7.
here. Let's see. So let's see what you wrote. Hold up. Let me resize this. Haven't considered the comma while serializing. Tried to combine iteration with recursion, which confused me. Okay, yes. Combining iteration with recursion, everything should be a discrete step. So that's a very big red flag to me. Remember the child's by drawing the stack is basically the opening close of parentheses in some states with help. Next time try drawing things, try different ways to traverse like levels by recursion. Yeah. So being able to separate traversal and recursion separately in your mind, usually you're only gonna do one or the other. You're very rarely gonna do both at the same time. So because the problem basically breaks down to can you recurse this and can you recursively traverse this and can you come up with a string representation for that traversal. That's really it. Walk through testing through the idea, making pseudocode, writing the test pseudocode. Remark must be more accurate while doing the test. Yes, you should be as detail oriented as possible without being overly pedantic or crazy about the details that are useless. Coding, testing the code, sure. Testing, found a bug, went back to test the original idea, pseudocode. Making a walkthrough to check where I messed up on the pseudocode, therefore I have time to be accurate, fix the code, test the code. Second time, okay. So let's see, walk through the first idea, testing pseudocode. So you got to like 15 minutes, then you got to the first code. So the second part is probably what was harder. Okay. So let's skip to the first part. The first part is just serializing, and the second part is deserializing.
No, I actually did like the first one. Yeah, just like serializing.
So you only did serializing?
Yeah, just serializing.
So,
Okay,
yeah.
so it took you 40 minutes. That's a little bit concerning. Let's see why.
Yeah.
I'll verify. It's child's child. Like I will recurse. Okay, now let's and then start to do all the process right here.
Yes, because I think like I put in the end like kind of a reflection. If I did test like more accurately, I would like solve this in 26 minutes, just the serialized part,
Okay.
and I'll have like both parts done in the 40 minutes or
Okay.
less, like 30 minutes.
Okay, now I think I understand where the problem is. Give me a quick second to check. Just a second.
Like this.
Okay, so you're still coming with the pseudocode here.
My
Ah.
I'll take temp. It's gonna be the.
Okay. I understand what the problem is. I don't need to see anymore. So basically, I noticed that in the first like 15 minutes, you're basically just going back and forth. Between like, oh, I think I need to do this. Let me test what it looks like here. You're basically going back and forth between your pseudocode and then actually writing the idea. Does that sound about right?
Yeah, that's accurate.
Okay. The way you want to think about a lot of these problems isn't necessarily in terms of, oh yeah, what I do at this step. You want to think about it more in terms of what's the general pattern that I see. So let's wipe the board. Pretend that you didn't understand or know about this problem. So what I see is that the way like to think about it. Like let's say we went here, right? I see that I'm trying to come up with this traversal, and that okay. Well, I'm going to ask myself, what's the general pattern I see here? That's the question that you should be asking yourself when I see this. So let's say I came up with this 1, parenthesis 2, parenthesis 5, comma 6, whatever, right? So the question then becomes, when do I do a parenthesis? When I go into the children of that node.
Yeah.
That's it.
Like a level. Yeah.
Yes, when I go into a level. And then the second question is, when do I put in the comma, right? I do a comma when I'm listing out all the children. So in general, the formula is going to be node value, parenthesis to mark, going into a child, and then and then whatever value that child is, or represented by the traversal. That's basically the formula. So if I let me write that in your problem docs. Maybe it may be a little bit more clear if I'm not like talking about it. If I show you. Okay, so I'm in your problem sheet, right?
Yes.
Okay, so you have 1, 2, 5, 6, 3, 4, right? So we want to come up with a general pattern. This is the way we want to try and see this. So when I do this, let's say I replace it as X, Y, Z or whatever. Like pretend for a minute these numbers don't exist, right? So this red just basically means equals going into the children, right? And then for instance, out means done with showing the children. So then what this means is that if I had like X, for instance, Y, Z, A, B, C, then each one of these letters basically represents equals to traversal of the node. X or Y or A, da 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 da. Does this kind of make sense?
That makes sense.
Yes. So in other words, the pattern I want to do here is like recognize patterns, because that way you're not going back and forth. That will save you so much grief. Because what this means is that Y, Z, A, B, X, like here, just represents, hey, this represents the subtree.
Okay.
And so now once you recognize that, then you should be able to recognize that this was a recursion, just based on a traversal. Does that make sense?
Yeah, and based on that, I should like to derive my main algorithm, right? Like just based on the pattern. All right. I was like going back and forth just to fix like the best way to like put the parentheses, but yeah, as you mentioned, it should be implicit, like while recognizing the pattern.
Recognize things that happen over and over again. Pattern slash. So because like this is why like I say to study the patterns in grokking, because these are like it should be train your ability to recognize things that happen over and over and over again. And so when you do things like traversal, it's just that, except for the fact that I'm not giving you the pattern to begin with. In fact, you should recognize when things are traversal or when things aren't, and being able to group these symbolically. Because let's say I took a highlighter to this, right? And then I know I'm kind of belaboring the point, but I really want you to understand this point. So this will be green. This will be green.
Following.
This would actually, and because of that, this would actually have a parenthesis here. So then let me highlight this in purple. Or I mean, it's a fucking horrible color, but maybe blue is better.
It's understandable, yeah.
Yeah, but then now that you guess now that I'm doing this, then green here, and then this will be red, and then this will be value, right? So then let's call this magenta, and then let me separate this color here, and then let me highlight this and boom. Okay, now that I've drawn it out like this, does this actually seem easier to write a pattern for?
Yes.
Yeah. No,
Like the colors. Colors represent like the levels. Right? No, yeah, like the steps where it repeats, like red, open and close parentheses, like the ones in green. It's like the children's of it and things that I need to do inside. And the comma is like the other. It's pretty visible, a pattern. Yeah.
Right. And see, humans are very good at recognizing and approximating patterns. So you should really take advantage of that. And like sometimes it's only like 90% accurate, and then the last 10% is where you go to do the back and forth. But what you did was basically ignore this part, which is why the back and forth took so long. But the moment I color coded it, the moment I said this, it instantly clicked with you.
Yeah, for sure. I was able to explain for you in less than 10 seconds.
Yeah, exactly. So that's basically, I think, what's holding you back. is that you're not recognizing patterns in the code. So I think that's my only feedback to you. Other than that, I like that your opening hand was like trying to traverse, test, and go back. So that's a good mechanical skill to have. But it's even better if you can just like skip all that, you know?
Yeah.
Okay. So I'm gonna say that.
One question. Like you said, like this thing of me, going back and forth. Okay. But you want me to skip? All right. Is this more like when I have more ability to recognize those patterns? Do you mean this, right? Like.
Yes.
I just got a little bit confused because, like, first I had to write all this thing down and try to derive based on the walkthrough, and now just changing the approach a little bit.
Yeah. Right. It's basically like that. I'm just like, we're starting off with like the raw mechanical fundamental skills. Like anyone should be able to take a idea, debug it, test it, and run through it, right? Anyone should be able to do that at a very basic level. And all we're doing is just optimizing on top of that. It's like, hey, well, I can do this, but I can at least skip a large chunk of that work if I can recognize some patterns. And then I can still always adjust to it later. Like a good analogy would be like if I'm playing like basketball, right? You know, it's like if I'm working on doing a jump shot from the free throw, right? You know, it's like a dribble, legs, squat, and then shoot with a hand, like and follow through, right? But then now we're saying, hey, wait a minute. If I am like, maybe if I'm not shooting from the free throw, maybe I'm like shooting from like somewhere else in the mid spot. I can, don't have to be as rigid with the mechanics. I should still be able to do them if I need to. But there's like certain optimizations I can do, like with that.
Okay.
That
like, makes sense.
It's just a layer on top of it. But if it came right down to it, you should still be able to do it.
Okay.
So that's all it means.
Okay. I actually I think I sent a message for you like for this problems of this one. Okay, I went back and forth, but for the subset I had like this issue of like having trouble to recognize the pattern. Like for traversals in trees, it's pretty, let's say, easy for me in like to create an answer on top of that because the pattern is pretty clear.
Yep.
2 pointers also. But I think it's things of train more, like and put more work. I don't know, and like always thinking this recognize the patterns to like. I got the idea.
Okay. So let's actually. So you're talking about the compute valid IP address from last time, right?
Yeah, the one was on the coaching session. Yeah.
Okay. Did you do the generate subsets portion in grokking?
I did. I did this twice, like the generate subsets.
The entire section.
I did this twice. Yeah.
Okay, and it still didn't click.
Oh no. In grokking. Yeah, yes. In grokking. Sorry, I confused with API.
Yeah. Did you do that?
Yeah, I did. As I mentioned, for the first problems like subsets and permutations, okay, I got this pattern pretty quickly. But like like one of the problem challenge was easy for me because I applied the pattern. The one of like, I think is to generate all the abbreviations is one that I recorded, which helped a lot because I had to think only in the abbreviation part. But like the last one of generate a lot of like different trees based on a number, like this one really, I was not like connecting the pattern to how would I generate different trees, Okay.
I don't think I really understand what you're saying.
Let me try to explain like more slow.
Sure.
The ones for subsets and permutations was easier for me. Like I was able to recognize the pattern and apply it pretty quick. Like also based on the message you sent to me. Yes. Like think about recursion subset problems. Put and not put in a condition in a recursion call. That really helped. And even one of the problem challenge, this helped a lot because it was basically the same idea but more complicated with some things upon this, and which helped a lot. But for the two last problems, that was to generate different trees, different BSTs. Binary search trees I was not like clicking the pattern with the different trees. I don't think, does that make sense?
I think I understand what the issue is. So I think
Uh-huh.
it's pretty much the same problem that you had with compute valid IP addresses. I'm assuming that this problem still doesn't make sense to you.
Oh, now make. I saw the approach with using two force, and I tried to fit this into the recursion,
Uh-huh.
and as I had to say that I had to
Okay.
much more work to understand. Yeah.
Okay, so but do you understand at least the compute valid IP address problem first?
Yeah.
So I don't need to review that. Great. All right, so then let me log into Grokking and see if I can help you. Hold up.
Okay.
Because I was a little bit worried, like, okay, if like we did the problem from last session and it didn't make sense to you, and do a step by step. In fact, I would actually encourage you to try doing the IP address problem step by step on your own and make sure that you can do the step by step. So let's go ahead and open up Grokking.
Let me open that too.
Yeah.
Mention, like, I think we have 1, 2, 3, 4, 5, 6, 7.
Okay. Is this the which is this the third problem challenge?
Is which one? The one that you saw, right? What up?
Okay. Yeah, got it. Is this structurally unique binary tree? Got it.
Oh, the evaluate expression. I did this as well.
Wait.
I used the pattern, which helped a lot to solve. So the problem challenge 1 was good. I did it. But the 2 and 3 was the one that killed me.
Got it. Okay, so let's see what is here. Structurally unique binary trees. Given n, write a function to return all the structurally unique binary search trees that can store the values 1 to n. So they give an example 2 here to represent, oh, these are 2 valid binary search trees. 3, here's a 5 valid binary search trees. Okay, so then basically we're looking at patterns where you have 1, 2, 3, 4, 5 at the root, right?
Huh.
So the way I would see this problem, and look here, I actually haven't done this problem, but the way I would have tried to do it is like, okay, looking at the pattern here would be like trying the very dumb, like, naive solution is trying every single possible arrangement of every single node, see if it's a valid binary search tree, and then if it is a valid binary search tree, add it as a valid solution, right? Of course, this is like very wasteful. We don't need to do that. In fact, like the reason why is because like there's so many invalid cases, right? So if I put 5, let's say in this case, 3 at the top, I know that I can't have 1 ever on the right hand side, and I can't have 2 ever on the right hand side, right? So that prunes some of the options, right? So I don't need to try any permutation of that, like 3, 1, 2, or 3, 2, 1 on the right hand side. Those will never be the case. So the optimization would be to start from a ground up approach to say, hey, I know that this place, this node, this value belongs here. And then to go from there and say, what are all the other valid possible combinations? So for instance, I would say start with, for every single node, put that at the root, and then pass that subset into the left, pass part of that subset, every single possible combination, into the left-hand side, and then pass every single possible combination on the right-hand side. So what do I mean by this? So let's say I take the value 1, right? Then all the numbers that are greater than, and then I would chop up the the set of remaining numbers into numbers that are greater than 1, and the numbers that are less than 1. And I'll take the subset, pass it down to the left-hand side, and then pass down the set that right-hand side, right? And then that function will return to me back all the possible trees that can possibly be created with those nodes that are structurally unique, which is the premise of the problem. So my contract now will be give an array, get back all the possible combinations of nodes, and then just link them up to my node here. That's basically how I will solve the problem. I think that may or may not be what they do here, but I'm gonna check.
That's the solution.
That's
the solution.
Yeah.
I checked this very thoroughly. Yeah, and that's
Okay.
the solution.
Because I didn't even look at the solution, but you notice like what I did there, right?
Yeah, you just the pattern, like to try both sides. Yeah, I generate like all the possibilities and just stay on that and didn't think of this side thing. Yeah.
Part of it is a pattern. The other part is recognizing what is inefficient about my solution. So remember, I remember how I think I mentioned before, try to come up with the dead brain, easiest, naive, most simple solution that I can think of. Well, the most simple solution I can think of is constructing an arbitrary binary search tree with every single possible combination of nodes. Like it's just
Yeah, I did this. That
Yes.
part was good.
Yes.
But when I was trying to optimize upon this, was the problem. Yeah.
Yeah. So what is wrong with it is because we're going to try too many different configurations that will be invalid. And the moment I recognized that is the moment I said, okay, well then all I need to really do is concern myself with all the valid sub problems, right? All the valid binary trees. That's it. That's all I need to think about. So then that means that my contract will now be still the same, right? Given a list of nodes, give me back all the binary trees, and then just attach them to a node that I've selected here. And then I'm going to try that for every single possible combination of nodes. I don't know if that was a big jump in logic or not for you, though. That's what, if it's a big jump, let me know. But it should be very logical.
Oh, it's logical, but the thing is, I was like, while solving this problem, I did the brute force solution. I identified the inefficiency, as you mentioned, but I said to myself, okay, now I should to apply this subset pattern and try to see where it fits. Let's see. And that was not so clear for me as was with you. Like I was trying to, okay, let's see what I did in the problems of the past. What can I use of this, to try and not try, I was not fitting. I don't know.
I know what the problem is. You're trying to you're trying to use what you memorized. That's not what I'm trying to get you to do. I'm trying to get you to think logically and build your solution from the ground up. So let me go to your problem sheet again, and let me see if writing it out will help you. I know you understand it, but I want you to, maybe if I show it to you on paper, maybe it'll be a little bit different.
Okay.
So let's say a naive solution, right? Solution is try every single possible permutation of nodes in a BST. What's wrong with this? We will test and create impossible, invalid configurations over and over again. So, like I said, 3. Like if I do 1, then I know that. No, yeah, if I have 3, then I know that 1 or 2, 1. This will never happen. So, let's say I have 3, 2. This. And then I highlight this. So this is the problem. So all I need really is just to make sure I'm only dealing with valid nodes. Valid nodes and subtrees. So so if I do this, then 3, let's call this x. Let's call this y and then x, right? So then x equals all the valid subtrees. All the valid subtrees given n array. And so based on the rules of a BST, only elements that are greater than y can belong in x. So does this sort of thinking allow you? I guess now that I've written it out, do you think you can copy this kind of thinking?
Yes, I can.
Perfect. Yeah,
I will try to do this again. Following this thinking and try to apply to the other. That is basically the same thing, but he doesn't want the trees. He wants just the number of trees that can be formed. Yeah.
Right.
Yeah.
I don't want you to think that of binary search tree dealing with only valid nodes and trees. I want you to think more in terms of in general, because this can apply not just in binary search trees. This can also apply for heaps and anything else. The question you always want to ask yourself is why? What is wrong with this? How can I not walk down that path? It goes back to the same idea of where am I going to go to die? So I'll never go there. And this is I think the big question. Where am I going to go die?
Okay. So, are you speaking? I think the connection broke just a little bit.
I wrote it in your problem sheet, but basically I wrote down, make sure I'm only dealing with valid nodes and subtree, and then it boils down to the same question of where am I going to go to die, or in this case, death is being hyper inefficient. So that's basically the question I think you should probably ask yourself, like how do I not go down a inefficient route? So
and like based on this, try to like, okay, what can I do better here, right? To not die. All right.
yes. I think if you look back at like your own approach, actually, do you have the practice diary for that problem?
I have. Let me just go back here.
Yes.
Tell you the row.
Okay. Is it the row 46?
Is the evaluate expression unique generalized? Oh yeah, is the on line 46.
Perfect. Cool. So let's see what you wrote down. Broke down the problem into 3 different steps while breaking down the bigger picture. The 3 steps are create the permutation of good, create the binary search tree from a given sequence and validate another binary. So create all the permutations of the given sequence to create the binary search tree. Okay. Create the binary search tree from a given sequence, and then validate it. Okay, sure. Since I draw out the pseudocode, too long for each one. Okay, since I draw. Go ahead.
That was like basically I divide in 3 steps. Like one, creating the permutations, like as you mentioned, like from where I can start this binary search tree, and the other is like to validate if the trees I was creating was valid, and the third was to like check if already exist on the trees I've created in the past. Yeah, that was like my naive approach. I tried like then to improve upon that. Yeah, I just focus on like make this work.
Okay, I'm going to say that really here's something I noticed. This validate if another binary search tree already exists. That's a little different than what I did. So you notice like you create the permutations, yes. You create a binary search tree from each of those sequences for like all the possible combinations, yes. But the validation if that binary search tree already exists, that's not a thing, because the reason why is that when you're generating subsets or you're generating trees, like these are fundamentally different. At least in one sort of way, because if you look back at the 312, the thing I've noticed in the problem sheet, you notice that these 2 trees are different. So there's no repeated binary search tree here. Like even though they're both incorrect, they are both different.
Yeah.
Okay, but yeah, so that's probably like one of the things is that I think you might have misunderstood. Validate if another binary search tree exists. You're not looking to see if it exists. You're looking to see if it's valid. That's the objective here, right? Because if you look back at the problem, it's like write all the structurally unique binary search trees that can store values 1 to n. I think yeah, it's talking about like the valid binary search trees. I think I wish it kind of said that explicitly, but that's kind of something that you need to notice as well. So that's actually the difference here, because notice that like in the problem they actually don't say that. It's kind of interesting, yeah. Implicitly, I think is that they're all valid. So I think I think
valid
that
ones.
Detail.
The valid ones.
Yeah. So it's not the one that exists. It's the validate. Okay. Yeah. But either way, validate it and then see if that base tree to this. You shouldn't need that last step. So okay, but anyway, keep going. So I draw and create the pseudocode for each one of the steps. It took too long specifically for 2 items. Therefore, next time to be more concise in things that are trivial. Yeah, verify. So my guess is that you spent a little too long on this naive thing. Yeah.
Yeah.
Okay. So the question you want to ask yourself is, what was the insight that was needed? Okay. Address.
The last point was basically all you said. Like maybe see the inefficiencies and try to see where can I reuse and derive the pattern like on this problem.
Part of it's deriving the pattern. Sorry, go ahead. I keep interrupting you. Sorry about that.
I took too long on like the naive solution. I should like spend more time like investing on like trying to break the inefficiencies, and that was a mistake of mine.
Yeah, because you already know that this is a shit solution. You don't need to write it out thoroughly necessarily, unless you don't have a clear idea of what exactly entails. But if you have a clear idea of exactly what entails, then that's a different story.
Okay.
But yeah, like you should already know, like it's shit. There's no need to pursue it.
Mhm.
So it's like I don't even need to write down the solution into that. I don't need to write the code for it. I already know it's bad.
Okay.
So, but like notice, I just need to draw out like what sample solution I can is inefficient and why it's inefficient. So being able to do this very very quickly is going to be very very key to doing these problems quickly.
Okay. One thing, I think like the tip you gave me for like the subset problems
Yes.
and for I don't remember. That was like another kind of problems that you really gave me a tip.
Okay.
Really helped me. The subsets and like the parentheses. Like I want to solve this naively, which really helped me, and I applied this to different problems, and like it fits. Like I was able to solve a lot of problems.
Okay.
But I think this one, like with tree and different structures, I will try also the one to apply also in the one of the IP addresses. And there's one more that is great code that is on
Okay.
API. Yeah,
Okay. Do you
I
have
think will be a good practice. Yep.
Sure. Do you have? And I think you want me to look at the other problematic one, or was it this one?
I would say that the other was good, but if you can go ahead, just go for it.
Sure.
But I think the bigger problem was this one actually, the one I'll gain more, more insights. Yeah,
Okay,
the one would be.
Okay, and we reviewed this one already, so let's look at your problematic one.
Okay, so the problem is count of
Actually,
So given
the problematic was the one of the tree.
Ah.
Actually, it's gonna be redundant. Yeah, I will
Yeah.
try to solve again. I
Okay.
think it's not gonna be good if you look, because you understand what I mean, right?
Yeah, I know. I'm just looking at it very quickly, just to see like if it matches up your notes, because I think being very accurate on your self analysis is also very important. So let me see.
I tried to generate like the trees. I messed it up sometimes, and I fix. I was trying to do the same thing as you said, but I did like inefficiently. Yeah.
Yeah. Well, okay. This tells me a few things actually. The first thing is that, well, you should already know. You should be able to do this imaging in your head. You should, and the thing is that, like, yeah, you should actually you should already do this. You should be able to do this in your head actually. Because then all it is just like for every single element in an array, create a create a node, and then come up with every single possible combination and permutation of array splitting. So
Yeah.
That's basically, and then pass it to the left side, pass it to the right side. That's it. And
Yeah.
I don't need to necessarily write the code for that, but good.
Yeah, I was not connecting to this. I was trying to. Okay, how can I reuse this tree? Yeah, the thing you just did so quick.
The reason why is because I just
yeah.
kept it simple.
Yeah.
So remember, like the
I
whole
was
thing?
trying.
Yeah, you can remember the whole.
Yeah, I was trying. Yeah, the simplicity. Let me just walk through my thoughts during this part.
Yeah.
I was trying to. Okay, let me first generate all the trees for the number 3, and okay, that's what I did. And then I was trying to analyze, okay, from this, how, like, I can make those trees, like, I can generate those trees, like, reusing some part. I was trying to find an efficiency. And I think that was the part where, like, it led me to not solve this. Yep.
Yeah, you're
yeah.
thinking about inefficiencies in generating the tree itself. That's the wrong thing. You're talking about. Remember, the objective is to solve the problem, and you're talking about inefficiencies in an implementation, not inefficiencies in a solution. There's a very big difference.
Implementation, not in the solution.
Yeah, okay, is that not clicking with you, or do you need me to explain it, or?
I think he can go more over this, because the implementation, not in the solution, right?
Yep. So there's two different ideas of inefficiencies. One of them is inefficiency in implementation, inefficiency in solution, right? So when we talk about inefficiency in implementation, what do I mean? I mean, like, let's say let's say I have a idea of actually let's use your thing, right? You say I want to generate all the possible combination of of trees, right? So then the more complex way of me doing it is like iterate through all the let's say character numbers, create a node with number at I, and then what's an inefficient way of doing this? I would say let's say create the subsets. Let's create the subtrees with split between index at I 0, I minus 1, and I plus 1 to n or something like that. You get the idea. And then and then combo that together, right? And then let's say I added in like some validate the binary search tree before adding to solution, right? Well, the inefficiency here is that I don't necessarily need to do this at the time of creation. I can literally just do this at the end. And even though what's it called? Even though this does make the solution faster, it's still a shit solution.
Yeah.
Why?
Because you're generating those useless trees. Yeah.
Yes, you're still like it doesn't matter whether or not you do this at the beginning or you do this at let's say the after generating all solutions. Like this is just if you're thinking the reason why this would be called inefficiency of implementation is because you're trying to generate all the possible combination of trees. This only comes about when you're focusing on the wrong thing. Because remember, the problem is we want to generate all the valid possible combination of trees. Because optimizing this versus this just optimizes this shit solution. It doesn't optimize this objective. So
yeah, that makes sense now.
Yeah. So you're just it basically means that you're focusing on the wrong objective.
Okay. I just took a very big note of that because few points I think I got better, but yeah, new ones are appearing. So I need to be very aware of this.
I would say I recommend reading my section on what is blocking you, how do I unstuck stuff. I think that might help you with logical thinking. Because this is I would say this is one of the more hard skills of engineering actually. The reason why is because knowing what you need to know is very difficult. It's being able to think and understand what the path is to the solution is an actual skill that'll serve you not just in coding interviews but in engineering in general. So this is actually losing sight of the forest for the trees. It's not easy. But being constantly aware of when you stray from your objective is going to be very helpful. So I keep a lookout for that.
Okay, I will. And just one thing you said, like those questions, even though they're like more puzzles, but they really help like in the engineering process, as you mentioned, for sure.
Yep. Anyway, there's definitely a lot to talk about here. And I still think you're quite a way off. Of course, like a lot of these are just me trying to fix your approach. And hopefully, it seems like it's getting a little bit better, but slow steps once at a time. And hopefully, like each of these tools that I'm giving you and to think about is going to help you. So,
Cool.
Is there any other problems that you want to talk about? Any other things you want to discuss?
Just give me a minute. I think there's nothing else, but let me see if I missed some detail.
Yep.
Okay. Just complementing what you said, like just completing what you said. There was one problem that like actually was one I did Saturday.
Okay.
With a friend of mine, like just to pinpoint where I am, And I did exactly this thing that you said for me. I think I focus on the wrong part of the problem actually, and I just trying, And later on, when he said, "Man, I think it's good," so we stop here. And why won't you try to go in this direction? Because I guess that here is gonna be the big problem. And I solved the problem in a matter of like 5 minutes. You know, like because I was like trying to think in a way that was not the core of the problem. Yeah, and like just a little bit to add here. Yeah.
That's fine. Yeah, is this the wild card matching one?
Yeah, the wild card.
Yeah, my guess is that you're trying to optimize a shit solution, trying to make it a little bit faster. But then, if the answer is fundamentally flawed, then it's there's no point in trying to optimizing it. You know, again, like this whole thing of generating a possible combination of trees is like it doesn't matter whether or not you validate before or after. That's the wrong thing, because it's still like fundamentally shit. You're still doing a lot of extra unnecessary work. You want to be faster. Like even though this is a correct solution, this validating before or after doesn't change anything fundamentally or materially. That's really it. So that's just kind of like what you need to ask yourself. Does working on this change? Work on this make me progress to the optimal solution to the let's say problem. That's the best way to think about it when you think back on it. Or like I guess a little small reminder to yourself, like, hey, is it really worth trying to do this shit? It's like, is this is optimizing this goal? Is this the most I can? Is this the fastest I can get? You know, et cetera, et cetera. Just keeping that little question in the back of your mind is going to help you.
Actually, all the points you make for me, I put them on the side of like my monitor, so I can like internalize this and not try to repeat. You know. So I think I got new points to work on.
Yep, it's a long path. And I would really be happy if you implement it the next time I see you. Yeah. And I want you to make this. I want to make you make all these a habit. Remember. So.
Yeah. Okay. Sure.
Are there any other questions or problems that you want me to go over?
Yeah. For now, I think was that one. I was focusing much more in like. Doing my solution and then really analyzing where I could have done better. So I did not. My pace in terms of problem was much slow, but in terms of quality, I think got really better.
Okay,
so,
that's fine. I'd rather you be slow and correct than fast and wrong.
What?
I'd rather you be slow and correct rather than fast and wrong.
For sure. Yeah, I get much more out of those problems actually.
Good. So yeah, keep going with what I've assigned you. If you manage to run out of it, I want you to do the second part of the what's called the serialized deserialized problem.
Okay. One question I was having while practicing. Those problems that, for example, of course, I will redo them, but those okay, do you recommend I'm gonna like redo those of binary search trees as well, right? Like those that I didn't progress anything. And okay, I'm gonna go over all of them.
Yep, I would recommend you do that and try to keep this thing in mind. Every single step you do, make sure that you're making progress towards the actual solution. I think there's plenty of homework there, regardless. But let me know if you run.
There is. Probably not, but yeah.
Cool.
Okay, man. Right. Okay, thank you very much. I think those insights helped a lot and will improve a lot, actually.
Cool. Sounds good, man. Then I guess I'll see you on Saturday. Let me know how things go.
I'll let you know. Thank you very much, man. Take care. Bye.
Take care. Bye-bye. Okay, cool. Yeah, so let's see what you guys said. Commenters are less likely to be paid for their thoughts. Yes, that's correct. Commenters just basically are random people on the fucking internet, right? So I think it's just human mentality to want to belong to part of a herd and to not really make wrong decisions. I think that's, like there's safety in numbers, that sort of thing. And I think just knowing that people can vote on the hive mind and just join the hive mind, I think gives people more confidence. Whether or not it's the right or wrong answer is immaterial. It's more so that I want to be validated. I want my choices to be validated, and that I want to make sure that I can't go too wrong from the herd. I think that's basically the bottom line. Google coding exercise. How long do I have to wait for them to get back to me? Any ideas? I want to know if Google ghosted me. Google takes forever, man. I would say just keep progressing. I think that the longest I've had to wait was like 6 to 8 weeks for someone to get back to me. So I would say don't worry too much about it. Do you have any tips on coming up with a good name for a startup? Honestly, I don't really know. Honestly, I would say just take any word in the dictionary and remove all the vowels. There's your startup blank. Like actually, let's try that. Random word in dictionary. Let's try that. Random word gives xylo, whatever the fuck this is. I don't know. Wood carving. So let's see what happens if I take that and then just make a... Hold on. Let me bring up a subline pad. Okay, so let's say xylo. So let's take away y. What should we call y vowel? Log. L-Y. L-P-H. L-graph. Actually, what happens if I put a y in there? Okay, this looks a little weird. Yeah, this looks a little weird. How about Zephorus? Zephorus, yeah. Yeah, Zephorus. There we go. There's your startup name right there. I just like tweaked around, like just replaced PH with F. Took out some of the vowels. I don't know. Slow and correct. How much speed comes? Just more practice? Yeah. Basically, slow and smooth, smooth is fast. It's like fucking making a jump shot, right? From a free throw. You just take the, you just fucking practice the mechanics over and over again. Elbows tucked in, lift, fingers straight, push, and just do that over and over again, right? Just very slow, making sure you do every single step. And then eventually you realize, hey, I can just do this, faster, faster, faster. It just becomes habit. That's it. Like, does speed come from hard problems? Like, no. Speed just comes from recognizing patterns and recognizing that what you're doing over and over again. That's it. It's like, how do people get fast at anything? They just started really slow, did it correctly, and realized they don't need to keep checking themselves every single time, you know? And then realize just, hey, this is smooth. Like, I can just, you know, tuck elbow in, shoot, and then eventually they get, you know, they just do each one mechanically and individually. Now, that means that they can always go back to the basics and break it down mechanically step by step if they need to. But, and, you know, they want to make sure they're not skipping steps. That's what we call being sloppy. So, sliding window median. What about the sliding window? Yeah, I mean, let's come up with another startup name. I still think that this idea of like removing vowels and then torturing it to actually come up with a name is actually pretty good. So Indite, N-D-I-T-E. Yeah, end date. End date. Yeah, end date. Or something like that. It's like eHarmony or some shit. Or like this could be like some Unix time thing. I don't know. I feel like coming up with like fucking startup names is actually good. Z-Focus is actually pretty good, actually. Zephorus, Z-Focus. Is grokking the best website to learn those patterns? Yeah, pretty much. I think they'll train your pattern recognition. If you look at my guide, I basically explain how to do this step by step. But basically, you see the pattern, and then you recognize the characteristics of the problem that lend itself to a pattern. That's basically what you really need to do. It's like noticing things that happen over and over and over again. Like humans, and just like being able to say, hey, I've seen this before. I recognize that I can handle this way. Then just going along with it. That's really it. It's like following the path of least resistance, without like getting sloppy. Anyway, I did promise you guys the I guess the Coca-Cola thing. So let's look at the Coca-Cola 10K for the past 5 years or some shit. Annual filings for Coca-Cola. Filtered by year, 2021, 10K. Let's look at the PDF. 194 pages. I don't care. Consolidated financial statements. So, okay, let's look at the past 3 years, right? Operating revenues have been, 10% year over year. Pandemic, okay, fine. I'll bring up other previous numbers before. But let's look at the net profit. Operating income, net income. Where's net income? Income tax. Income. Consolidated net income, yeah. So let's say that this is like, what, compound. Let's say 5, let's give this like 5% year over year. And then the consolidated net income's like what, 10%? Yeah, let's say that this like 10% or some shit. 10% year over year. I mean, you can do this. You can do this like what's it called calculation yourself. But essentially, you just want to take like how much the operating revenues grow, and then compare it to the net income and the all the operating expenses that you got going. So it's like gross profit, and then like minus this is the operating income, right? So then this is like all your expenses and shit. So what you really want to do is look for businesses where the revenues keep growing very, very steadily, and then that the what's called the profits, the operating expenses don't grow as fast. So you can see here like relatively steady actually. So you can see here like these only grow by like maybe like, even though like the revenues grow like by 10% year over year, the expenses don't really grow by that much. They're like basically 5% year over year. So you get 2 for 1. 10% year over year, and then only 5% year over year growth, and then you get 10% net income or some shit. You get my point here. It's actually, you just have to repeat this exercise. It's kind of hard to do it with the 2020 figure, because otherwise you're not gonna know how to read what's it called, down years. But you can repeat this exercise with any company, and that's why I say that Coca-Cola is like basically a software company. What's my primary programming language? Java. I'm literally an old monkey, dude. Like I use like Python, and then I use Kotlin on the side. But the one I'm familiar with is Java. And if you told me to do a coding interview, I'd just do Java. Anyway, I think that's all the questions that people really have. I think, yeah, that's basically it. So I guess we'll stop the stream for today. Thank you all for joining. We'll be doing another stream on Saturday, maybe at around 11 a.m. Same client. We're going to be on the 3rd week of working with him. Hopefully you guys learned something from this session. Thank you all for joining me. And I'll see you guys on Saturday, 11 a.m. Pacific Standard Time. So thank you all for joining me. Have a good night.